Hello everyone! Today we are going to explain the core concepts of chapter 4, getting started with computer vision. Instead of just showing a basic camera feed, we will focus on three fundamental scripts that demonstrate how Raspberry Pi 4 processes visual data using the OpenCV library. So let's start with the first. Our first script demonstrates how the system handles static images. When we use the CV2 imred function, OpenCV doesn't just open a picture, it translates the image into a multi-dimensional NumPy array. So this means the computer is reading raw mathematical data, pixels represented by numbers. After displaying the matrix using CV2 im show, we use CV2 im write to save a copy of this array into a new file format. So this proves that our environment is correctly set up to read, hold, and write graphical data into system memory. Let's see how it works. In this case, it's a picture of a fox or Cerrito, and here we are. Here we have the image. So as you can see, there's a lot of pixels here and a lot of colors. So for example, here is green, and as you can see here, if we put here, it shows more red than green or blue. In the grass, it shows more green than red. So this is an example. Let's go to the butterfly. At this point, we have a lot of red and almost nothing of green or blue. So let's continue. Let's close this. Let's continue. Processing full color video in real time can be computationally heavy. This next script captures the live feed from our USB webcam and applies a color space transforming using CV2 CVT color. We convert the default blue, green, red channels into a single grayscale channel. By stripping away the color data, we drastically reduce the processing overhead. This is crucial optimization step because most advanced tracking algorithms work much faster and more efficiently using pure luminance rather than full colors. So let's run, and it will appear here. Here we have our camera with gray scale and original color, as you can see here a little bit. And let's put the fox here, here, and here. There we go. So this is the camera, the webcam camera. And let's wait a few seconds, or maybe not. Sorry. So I didn't know what happened, but it's working now. So as you can see here, we have our picture in color and a grayscale. It is using the webcam camera. So here you can see is the camera. It's nothing of the other world, but yes, it's working and it shows the image in color and in a grayscale. So let's continue with the next one. So finally, We apply geometric rendering over our live video using functions like CV2 rectangle and CV2 circle. While it looks like we are just drawing shapes, this logic is actually the foundation for mechanical interaction. The bounding box isolates our region of interest, and the red dot calculates exact center coordinate. This specific data extraction is exactly what we need to calculate the precise x and y coordinates to guide a robotic arm, for example. By identifying the center of an object on the screen, we can translate those pixels into physical movements for a manipulator to grasp a target. So, for example, it shows a rectangle or image. Uh, the this shape to this shape, the color and the thick. So this is the same for the circle. That the circle is in the middle of the image. We show the image here. It's the camera also, so you can see here. And the line that is recording that part of the image, and the text. In this case, we put hola. So lastly, or title. So that's it. And thank you for watching this video of the Raspberry Pi 4. So thank you, and see you in the next practice. Okay. Sorry.